Quick roughing is a new three-axis operation subtype that efficiently removes large volumes of material in planar levels with reliable tool and holder collision and gouge detection. It is recommended for quick programming and machining of simple prismatic parts, mold cavities, cores, dies, castings, and forgings with contoured shapes. Quick roughing is simpler to use and generates tool paths faster than cavity milling. It provides efficient and safe removal of blank material, yielding a reliable stock model for subsequent rest roughing operations. We'll begin by creating a new operation and generating the tool path. Range type can be determined automatically, or it can be user specified. The default is automatic. Automatic detects the top and bottom of the part and uses the volume as the machining range. If the blank extends above the part, you can reposition the top plane using the Specify option. The cut range can be specified by keying in values, graphically dragging the arrow, or selecting faces. Cut levels mode may be determined by constant depth or by number of levels. Top-off flat faces is on by default. Flat faces that are less than the specified minimum width are not topped off. This prevents the unnecessary cutting of narrow steps. The minimum top-off width can be expressed as a constant value or as a percentage of the tool diameter. Corner smoothing prevents an abrupt change in tool direction and allows you to maintain higher feed rates and tool stability. There are three smoothing options. None does not smooth corners for any cutting pass. All passes smooths corners for every cutting pass. All but last pass smooths all corners except for the cutting passes closest to the part. Quick roughing uses a single hybrid cut pattern which is a combination of follow periphery and follow part. This behavior can be illustrated by three use cases, each with a different type of cut region. Use case number 1 occurs when cut regions are open on all sides with no walls. This case uses the follow periphery pattern, cutting from the outside in. Use case number 2 occurs when cutting semi-open pockets. The tool plunges outside the stock and offsets are open. This case uses the follow part pattern, cutting from the outside in. Use case number 3 occurs when cutting closed regions. The tool ramps inside the pockets with closed offsets and uses the follow periphery pattern, cutting from the inside out. Small area avoidance prevents tool paths from being generated in closed regions that are smaller than the specified region size. In this example, the cut region is larger than the specified region size of 50% tool diameter, so the region is cut. If the cut region is smaller than the specified region size value, then the region is not cut. The minimum ramp length must be less than or equal to the specified region size. Otherwise, the region size value will be changed internally to the specified minimum ramp length. Click No to continue generating the tool path and internally change the region size value. Click Yes to cancel the tool path generation.